Okay. I think we'll maybe start, ladies and gentlemen. I'd also like to thank everybody for sort of coming along this evening. It's quite a different evening, I think, here at the London Roman Fort. I just want to start off with a few housekeeping, just sort of go through the basics of health and safety. We're not expecting a fire alarm tonight, but should a fire alarm go off, you'll know about it. It's going to be lots of noise. We need to make a way out. Obviously, the exit's behind us there. Should it be the exit that's on fire, we've planned Stephen's just going to punch through the wall. Okay, a nice 84-inch hole through the wall. Okay, so there's that. There's if you've not found them already, the toilets are just outside, sort of the other side of that wall. There's a toilet block there. However, if you are going outside, just make sure with the steps and everything, it is uneven ground, you know, sort of common sense. Don't trip over, please. Don't try and go to the right because there's no barrier there, but I think there's a chair sort of blocking it off. If you have got your phones not on silent, please put them on silent because there's nothing more annoying than you know, sort of people's phones going off. If you don't mind. Was the other thing I need to mention that we're going to have an opportunity for sort of photographs and things at the end. But you know, while sort of Stephen's talking, if you don't mind, you know, don't use a flash if that's okay. You know, rabbit in the headlights sort of thing. Okay. I suppose sort of the opening thing is why are we here tonight? And the reason we are here tonight is because all of you. Okay. Stephen's here tonight because all of you. Okay. It's what you do. Okay, it's what you're interested in. We all share a common interest here, a common goal. That's not just astronomy. It's not just solar astronomy. It's spreading it. Okay, it's the outreach side of it. It's sharing it with young people. Well, not just young people, you know, but sharing it with people. I think probably every person in this room can remember sort of the first time they looked through a scope and they saw Saturn. You know. Or you know, you looked at the moons, you saw the moons of Jupiter through binoculars, or you know, there's a whole list of things. These things that people remember. But the important thing is, we're all people who share this. Okay, we're people who share it with other people, and that is the important thing. That's why this evening's happening. We don't just have Stephen here this evening. We have some other international travellers, celebrities joining us with us. We have Walter. Swiss Walter there in the middle. Walter, give everybody a wave. Okay. Walter's travelled over from Switzerland for this weekend, if you like. Stephen and Pedro will come to you next. Didn't know he was there. Walter's a great guy. If you go on the Solar Chat forum, you'll see him there, Swiss Walter. Okay. The chances are he's replied to your post. He replies to everybody's post at least once. He's come this evening to collect some money from Richard. Richard's been doing his daily sunspot photos. It's no good hiding his senior. Okay. Richard's been doing his daily sunspot numbers, and Walter and Richard have a deal that if the sunspot number is below 100, then Richard owes Walter money, and vice versa. Okay, and so far this year, most of the time, sadly, Richard, you've been sort of owing the money to Walter. There's no other way we can put it. Walter is a great guy. He's always there on the forum for help. If you are somebody who's modded a scope or done anything like that, again, the chances are Walter will have made a contribution to that discussion. I've visited Walter a few times. He has more telescopes than anybody I know in the world. I think when we were there, we decided to count them. We got up to about 20-something, in the mid to 20s, something like that. But that doesn't count telescopes that aren't working, or telescopes that are being modded, or bits of telescopes. Okay, so you know, it's poor Barbara. It's costing Walter a lot in pairs of shoes to keep Barbara happy. Okay, then we have Pedro. Okay, Pedro's travelled over this week from Portugal. If you haven't seen Pedro on Solar Chat, Pedro produces absolutely fantastic solar images. You know, they are some of the world's best, they really are. But I strongly urge you to have a look on Pedro's website, because not only does Pedro produce world-class solar images, he's also producing world-class images in deep sky, lunar, planetary. Basically, if it's up there, Pedro is at the top of the tree recording what's going on. But, again, coming back to sort of the reason for this evening, Pedro is a great supporter of the outreach, okay, of the Charlie Bates Solar Astronomy Project. He visited Tunisia with Stephen just recently, earlier this year. Yeah. And I know there's a whole load of different outreach events that Pedro's put on. Okay. Which leads me to the last person. Okay. If you don't know, this is Stephen Ramsden. Okay. Director of the Charlie Bates Solar Astronomy Project. Okay. Who I'm told for the rest of this evening will be from this point forward known as the captain. So, Captain, over to you, sir.
Hello, good evening. First things first, let's get our selfie. Anybody who knows me knows I'm the selfie man. Give me a wave. All right. Mass selfie, I like that. Let me tell you first, thank you so much, Astronomy for Fun, for existing, number one, for doing what you do, and for the invitation here. Very, very grateful. If you're having trouble hearing me, I apologize, but there are some empty seats up here you're welcome to take. Craig and everybody on Astronomy for Fun, I noticed the group maybe a year ago. I was just surfing the internet and saw Facebook, this group, Astronomy for Fun, and I just had some experiences that I would rather forget with some other UK astronomers, and they really, or you really freshened it up and made me feel really good about the situation here. So I decided to share the group on Charlie Bates, and with the 70,000 followers we have, and tried my best to get everybody I could involved. And it's now pretty much the best group out there on Facebook, if you ask me, for astronomy. This in the Pakistan group, and is anyone here not on Facebook? Has no idea what I'm talking about. Okay. The group in Pakistan, the Lahore group, and the Tunisians are, and of course Astronomy for Fun, are really pleasant places to be. So thank you for doing that, and keep it light, keep the egos out, and keep the science in. Gary Palmer, thank you for allowing me to survive what you call driving through London. Mark Townley, I also met up with, fortunately, a little more than 2 years ago, maybe, and he's the director of my program here in the UK, and he's a fantastic gentleman, and I'm ecstatic to meet him. I've never met him before, and I keep sending stuff over here for him to distribute, and I picked the right person. I'm very happy with that. The lecture is sort of light, but we'll get to what the Charlie Bates program is all about. I'm trying not to block the screen. I know I'm an enormous American. Would you rather have me over here? Or does it matter?
You're fine right there.
Okay. What does Rob Black say? We're broadcasting live on YouTube, and Rob Black is the director of the Australian program. And he's looks like a hobbit, sort of. And he's a great guy. I spent a month with him in North Queensland this past summer, and broadcasting.
Yep.
That's too late.
There we go.
Well, let's just. This is me. Believe me, nobody is as surprised as I am to be standing at Roman Fort lecturing to you Brits about astronomy, because if you told me I would be doing this 10 years ago, you would have been out of your mind. I have no idea why it's so popular, but the program has gotten very popular, and I think it's because of a few things we'll cover in the lecture. I'm not lecturing to you. I'm sharing with similar minds how I feel about the situation, and some people find some clarity from it, and if you do, that's good. I'm 49 now, just turned 49. What does I always say? Carl Sagan. If you guys have Sir Patrick Moore, we have Carl Sagan in the United States. Always been my icon, and Carl Sagan's my hero in science. I used to be in the military when I was young. I grew up poor, in South Atlanta, which is a bad part of town, and we had no choice. You know, it was either go sell drugs, get killed, or go to the military. So that's what I chose to do. And I got on a nuclear submarine at an early age, and spent the first 6 years of my young life underneath the Arctic Circle waiting to bomb the Ruskies, you know, back in the Cold War. So when I got out of that, I became an air traffic controller, and I'm now retired from air traffic control. I went to college off and on through those periods, both in the military and out. And my education is all in mathematics, some astronomy, a lot of physics, but I would not call myself an astronomer. I would call myself a science advocate more than anything else. I do have a lot of fancy titles, though, but those don't really matter. There were some teachers in the audience. How many teachers do we have? Mark, anybody else? Pedro, University of Lisbon. In the 10th grade, I was picked out, you know, I'm obviously big. Back 30 years ago, all this was up here, and I was really mean looking, you know. And you guys have rugby, we have American football. So the school teacher saw me and immediately said, "You're on the team, you know, that's all you're good for, shut up and play football." So that was it, you know, that's what I was. In the 10th grade, my physics teacher, Mr. Jaber, who was Syrian or something, all I remember is he had really bad breath. But he picked me out and showed me some science, and completely changed, in retrospective, completely changed the entire course of my life. You guys do that every day. You probably know it or don't know it, I don't know. But every single day, teachers around the world will say something or give some child some attention that no one else is giving them attention, or whatever, or her, and turn around a person's life. That is a noble thing to do, and I'm very grateful for what you guys are doing. Had it not been for this guy, there's no telling what would have happened. You know, who knows? It turned out this way because of someone caring enough to recognize the fact that I was a human being, for one thing, and also give me some attention and teach me some science. In the 10th grade, I won this National Science Foundation program, which is an American government entity. They sent me to college, my first quarter of college after my 10th grade year. So I'm down in South Georgia, and if anyone doesn't know where Atlanta is, that's where I'm from. It's a farming area. It's known as the Bible Belt. It's a very conservative part of the United States. I went to the South Georgia College, and lo and behold, Carl Sagan walks in. He's one of the professors. 1981. I had no idea who he was then, but this guy just released Cosmos, the real Cosmos. Was at the top of his popularity, and he chooses to take 2 weeks out of his time and come down and teach science to hillbillies, you know, rednecks, which is what I am. I was extremely fortunate to meet this guy. That's me there. You can see how brutally handsome I am. This experience over 6 weeks in the summer changed the direction of my life again. Just something that people decided to do. There was nothing in it for them. It's just they felt it was important. It's a good thing to do. Since then, life has taken a few twists and turns. From a goth band guitarist and drummer to coconut bra wearing psychopath to me and Terry Legault at Beach. My lovely wife, Natalie, she's an attorney in Atlanta. She couldn't be here. She's still working, and she's taking care of our dogs. And then this is how the twists and turns that life has shown me. Everyone in here has an adventure, and it's in their life, and it's a precious thing, you know. And the reason we're all interested in science is because somewhere along the line, somebody got you interested in science. Okay, you weren't born with a slide rule, even though some of you may think you were. Somebody along the line said, "Hey, come here and do this. This is cool." Okay. Charlie Bates. Let me go back to this. Charlie Bates, for those who don't know, was a air traffic controller, and we served in the military together. In the Cold War, a lot of different things were going on, and we were supplying weapons and special teams to the Middle East in those days to fight the Russians in Afghanistan. We went through that stuff together. We became air traffic controllers together. Then in 2007, he killed himself over whatever demons he had. His wife had died from breast cancer. Everyone's had these stories. I don't mean to bring these things up. But he took his own life. At some point, he made the decision that his life was no longer worth living and ended his life. That struck me very strongly. Everyone here has had epiphanies in their life. At that time, I decided to take a look at what I had and where I was and how I got here. And I had everything. Air traffic control is an extremely high-paying job in the United States. Uh, Driveway full of Mercedes, nice house, whatever. Then I realized that the only reason that I had any of that stuff was because of someone else taking the time to care about me and teach me some science. So that made me want to honor my friend. Charlie had nothing to do with astronomy, but I wanted to remember my friend as something other than the guy that killed himself at work. I wanted to remember him with something positive. So there's many reasons why I did this, but I was just, nothing special, just sitting around Georgia thinking about life, and it seemed like a good thing to repay society for what I'd gotten from society. I mean, none of us would be successful if it weren't for the infrastructure we live in and the people that care about us. Nobody does it by themselves. So decided that day to take all the money and the fancy stuff and the showering myself with goodies and, all the American stuff you see on TV. I was living that life and just, give it away. Do something with it to help society. So I founded the program and tried to decide on something that was good, a good vehicle to share science with students. And that's about the same time that PSTs and all that were getting really popular. Solar astronomy was still fairly new. And I decided, well, look, there's this fantastic thing in the sky every day. Everyone takes for granted. Nobody ever thinks about it. It's just there. Here's a solar telescope. Here's a brainiac with a bunch of science knowledge. And here's a big motivation to share it. Let's do solar astronomy. So for the people in here that have been astronomers all their lives, I have not been an astronomer all my life. I really don't even consider myself an astronomer. I'm pretty good at what I do, but that was an after effect of the motivation to share science to help my community. So I chose solar astronomy. This story, this object, this is a view from my balcony in Atlanta. This thing is there every day. It is the absolute most important thing in the universe for our survival. There's nothing more important. If anyone can name something here that didn't either come from this or was created by this, I'd like to hear it because that doesn't exist. There's nothing more important than this. I looked around in Georgia and I could ask 100 of my friends, educated friends, what's the sun made of? You get a blank stare. I don't know. Who cares? How does it work? I don't know. You could ask anyone in my state. By the way, I don't know how it is here. We have a 67% successful graduation rate from high school in the country, the United States of America. 67%. That's in the year 2013. That is absolutely ridiculous. I cannot stand by with that being the case. Okay, so I'll go back to this. Ask people anything about the sun, even some astronomers, and they say, I don't know. I don't know. It seemed like a great subject that needed to be taught. So I chose the sun. It's a fantastic thing. Who owns solar telescopes in here? Who has a solar telescope? So I'm preaching to the choir, as we say in the U.S. But maybe I can reinvigorate that in you. The fact that this 875,000 mile wide ball of floating science lab is out there for you to look at anytime you want. It's free of charge. It's just there. It's the world's greatest lab for your students or for you. And to look at it through these telescopes and see the things that are happening on it is absolutely incredible. I could stare at it all day. I love it. When you share it with a student, everyone here has probably seen Saturn through a telescope. And if you haven't, you should immediately. That wonder, that same thing that you felt when you're like, what the? You couldn't believe it. That's every day on the sun. It's every time I look at it. It's the same feeling. And to share that with 80,000 students a year, it's like somebody's pouring good into your head every time you go. It's like you're getting refilled with positivity every time you do it. It's a fascinating subject. I strongly encourage you to get more involved with it. And I kid online a lot about sissy astronomy and nighttime astronomy, but I don't mean any of that stuff. Astronomy is fantastic. It puts you in your place, number one, in the world. Lets you know that you're really nothing compared to everything else, and your problems are irrelevant. If you're the new zit you have on your face, no one cares. It's irrelevant. You can't pay the power bill until next week. Who cares? It really puts the universe into perspective and makes you wonder and maybe even realize, what it's all about. In America, people do this, and that's about it. you know, and that's probably the same way in a lot of parts of England. They walk around and do this, you know. That's not where it is. It's up there. Everybody has built-in telescopes. Just put them on, you know, just look up, and there's the world. The story of the sun's creation and formation is a fantastic story. This is a nebula. Most of you guys know all this, but I'm going to go over it anyway. This swirling mass of chemicals, hydrocarbons, molecules, atoms from other supernova remnants. You can see it tonight if you look up at the Orion Nebula or any other nebula. This is how stars are created. The story is fantastic. It's a great story. It motivates students. It's better than any sci-fi movie ever made. There's just about 1 million blocks between you and the student nowadays. When I was young, and some of us in the 60s, there was hardly any roadblocks between you and some science. Now, there's the entire internet. There's Lady Gaga. There's Honey Boo Boo. There's Real Housewives of New York. There's 50,000 video games. There's Facebook. There's Twitter. Gigantic gap between students or young people or anybody seeing reality anymore. This is a great story, and it shares easily with students. And for the more advanced students, I mean, the process, by the way, everyone in this room knows what this equation means. I hope, does anyone not know what that means? I could ask that question of 1,000 people in my state of Georgia, and I would also get 1,000 blank looks, empty stares. Okay, energy equals mass times the square, times a big number. Doesn't matter what the number is. This formation of energy is naturally occurring in the core of this massive ball of hydrogen, and it's why you exist. It's why we're here. It's why you're still alive. It's this process, the proton-proton cycle. The neutrinos have been recently verified, as somebody, you may have read that, creating this helium, which by the way is named helium because it was discovered by studying the sun. Helios means sun, that's why it's called helium. These simple facts of our existence are basically unknown to the general public. Carl Sagan had a saying, we live in a world completely dominated by high technology where almost no one understands anything about technology. That's never been more evident than right now. The sun rises every day. What was it, Gary? It's cloudy, you feel bad. If it's sunny, you work on your tan. That's about as much as anyone knows about the sun. We have a duty as scientists and people fortunate enough to know these things. We have a duty to share it with our community, with everyone else. A community that is educated is a better community, which means your life becomes better if you're in that community. I wish I could just, you know, Vulcan mind meld everything into your mind. Unfortunately, you have to keep these lectures short. I could ramble on about this forever. But just the state of society today is just shocking to me, that the stuff that people allow to go on around them. In London this week, I must have walked by and said hello to at least 200 people. Okay. Hey, how you doing? And nothing. Just, you know, they're scared to look at you. It's like they don't want to acknowledge you exist. One of the most densely packed cities in the world. And yet every single person is isolated in this cocoon where they're scared they don't, you know, you cannot look at anyone else. Don't look at anyone else. I find that remarkable that people live that way. Science will break that wall down. And sharing science, sharing anything. If you play guitar, if you like fancy cars, it doesn't matter what you love, if you have a passion for something and you talk about it with someone you don't know, you now have another friend. You know, I mean, America is terrible about this. Isolated. Everyone's scared of everyone else. Everyone has a gun. You know, the community I live in, there's at least 100 doomsday bunkers in people's backyards filled with beans and dried goods and water. Everybody has a weapon. It's nuts, man. What are you scared of? I mean, what are people scared of? I just do not understand. And part B, if there were a zombie apocalypse, do you really want to survive with those people? I mean, are those the people you want to be left on Earth? Science breaks down all of this, and sharing anything breaks down all of this. There's nothing to be scared of. Okay. Anyway, this whole hobby and nighttime astronomy, daytime astronomy, just about every practical science in existence is based on spectroscopy or manipulating the electromagnetic spectrum in some way and gathering data from it. Everyone here probably knows this. I'm going to practice saying it. The sun is a gigantic mass of incandescent plasma and gas. Okay? When you heat anything in science to 525 degrees Celsius or hotter, it produces visible light. It's a basic law of science. Lava is red because of its temperature. If I heat you to 5,000 degrees Celsius, you will produce a visible light spectrum. Okay, that's a basic law of science. The sun produces this spectrum. I keep hitting the wrong button, I'm sorry. Yeah, there it is. The sun produces this continuous spectrum of light, just like a incandescent light bulb, if anyone still has those. That's what it looks like when you split it apart, just like a rainbow. If you put some gas in between this light source and you, the viewer, whatever's in that gas is going to absorb a certain portion of the spectrum at a definite wavelength based on what atom it is. Understand? So if you got a cool gas full of nitrogen in between this light source and you, the viewer, you'll see some nitrogen absorption lines. The element absorbs a part of the spectrum. So if I'm a hydrogen atom and you're the sun, I'm going to absorb several different areas of the spectrum, and you'll see a black line where that light used to be. Absorption lines, basic spectroscopy. If you then, sorry, gave it all away. Now you don't know what the suspense. If you then heat this gas, or if you don't have a light source behind it and it's already hot, you get an emission line at that same wavelength for whatever atom it is. You got an absorption line when you have a light source, cool gas here, absorption line. Energized gas, emission line. Those spectrums that I handed out, I think everybody has them. If you look at this light right here, you will see emission lines from this light. That's how light works. It emits in certain wavelengths. That's why light is light. Okay? The sun has both of these things. The chromosphere of the sun being this gas cloud. You know, the sun contains everything from hydrogen to uranium in trace amounts, mostly hydrogen. You see absorption lines from all the different atoms in the sun's chromosphere. So when you look at the solar spectrum, you see this with a bunch of black lines on it. Thousands of them. Fraunhofer and the boys discovered this a couple hundred years ago. Inside those absorption lines, you can see a re-emission line because the chromosphere is now a hot gas that's emitting light. So I'm the hydrogen atom. I absorbed it, made the black line. Okay. Then immediately I want to get back to normal. So my electron in the third energy shell drops back down to the second energy level, and I re-emit light in every direction at the same wavelength. So what you have is a thick black absorption line and a thin re-emission line at the same wavelength. Everybody follow? So inside here, you have a thin re-emission line at 656.28 nanometers. That is what your solar scope sees, your hydrogen alpha solar telescope. The Etalon produces a strong peak at 656.28 nanometers and a couple of peaks on the side of it in different wavelengths. The blocking filter blocks everything outside of a little space either side of the hydrogen alpha line. What you're left with is a bright emission line, full brightness in your eyepiece. That's what you're seeing in your hydrogen alpha telescope. You're not seeing the surface of the sun. You're not seeing hydrogen fusion. You're seeing a re-emission line from a hydrogen atom at a certain wavelength. And the reason I tell you this is because it's important to put out the correct information when you're doing outreach. I've heard several people have to come up with some pretty spectacular answers to that question at outreach events. It's important to put out the correct information because it's better than any conspiracy theory you can think of. It's more fun than any science fiction. It's real. That's what you see in a hydrogen alpha telescope. This is a full spectrum shot of the sun. This absorption line is right here for hydrogen alpha. The re-emission line is right inside there. It's just a little bit too dim to see on this view. Your telescope blocks everything outside of here, and you just see the re-emission line. Sodium is another popular wavelength to view in. It produces these two lines, sodium doublet. I haven't seen a magnesium scope yet, but the magnesium triplet is right here. All these lines indicate atoms that are in the sun's chromosphere. Most of them are from iron. The more electrons you have in an atom, the more absorption lines they produce. Calcium is, it's always hard for me to find it. If I'm not mistaken, it's somewhere in this range. Calcium atoms in the sun's chromosphere, when they absorb the spectrum from the sun, they do the same thing. They absorb some energy. And in order to get back to normal, they dump an electron and become ionized. With that electron goes a photon at 393.4 nanometers. Okay? So absorption line's created up there in the purple somewhere. The re-emission line goes out in every direction, so only a small portion of it goes towards the observer. You look at that at full brightness in your calcium telescope. That's how they work. That's also the sun's chromosphere. It's not the surface of the sun. It's the effect features on the surface have on the chromosphere. Okay? That's about as technical as this lecture gets, by the way. So the rest of it's all down here. The features of the sun, basically I would like you to take away from this lecture and this portion. This is a prominence. This is not a prominence. Okay? When you're looking at a solar telescope, it's very common for someone to come up and see something shooting off the edge. Oh, look at that solar flare. Look at that solar flare. I mean, that's cool, man. If that's the way you want to do it, that's cool. But it's much better to put out the correct information and say this is a solar prominence, which is a mass of hydrogen plasma that's being guided along the magnetic field line from the sun. That's how the sun works. Magnetic field lines entering and exiting the surface and taking plasma and gas with it. That's what happens on the sun. Okay. The sunspots are the umbra is called, the dark area is called the umbra. The gray area around is called the penumbra. And you guys can all read, okay? There's granules. The surface is called the photosphere, which is what this looks like in visible light, or that is the photosphere. The atmosphere above the photosphere is called the chromosphere. And that's what we're looking at in these narrowband solar telescopes. In the white light scopes, you're looking at the photosphere. The photosphere is so bright, it completely overpowers the chromosphere. So if you have a white light scope, you're seeing all the wavelengths at once. And the red light and the purple light doesn't have a chance against all that. So the white light just completely overblows it. That's why white light looks like this, and you don't see the chromosphere on top of it because this is much brighter. Solar Dynamics Observatory is an American satellite, and it's orbiting the Earth. And any day, any time, 24 hours a day, you can get online. That's Mark's.
Sorry. Important message.
Any day you want to, you can get online and see the sun live in 14 different wavelengths, basically 12 wavelengths and 2 magnetic images. And you can see these features happening. These are real. This is all reality. Flare region, okay, magnetic field lines. This thing is available for anybody in the world to use free of charge. You don't even have to have a solar telescope to do solar astronomy outreach. You can just take a laptop to a school if you want to, or you can just look at it yourself. You can download this data within 7 minutes of it being recorded. You can make your own movies, make your own photos. I think it's more fun with a telescope, but this is available for you. That's a massive prominence. Pedro, was that one of your photos? Or was that? Oh, that was NASA. It's hard to tell NASA's photos from Pedro's photos. This is called a coronal hole. Everything in any of these images, in any narrowband telescope image, the brightness indicates the temperature. Dark does not indicate the absence of something. It indicates cooler something. So last year on Fox News in America, there was this story where the editor of Discover magazine, which is a popular magazine, got up on Fox News and said, a giant chunk of the sun is missing, and it's heading right for us. This is the editor of Discover magazine, Corey Powell. Fox News ate it up. They put it out, oh, we're all going to die. And it was completely bogus. That's how little anybody knows about what's going on the sun. A coronal hole is just a cooler area in the chromosphere. It's an absence of magnetic interaction in a certain area that just makes it look cooler. So whenever you see one of these images, dark means cool. Bright means light. Last Wednesday, there was a X 1.6 solar flare on the sun. It was a very unique flare, very unusual. I was at this school in Atlanta, which I'm always at a school every day when I'm in Atlanta, teaching students about solar astronomy. This is my chick magnet van here. If the girls get too close, their clothes fall off immediately. So, the older girls, of course. We watched this flare occur on Wednesday through clouds with some of the best technology on Earth that's readily available to consumers. You can go buy this tomorrow if you want, from any store in London or on the internet or whatever. Anyway, this flare I was just lecturing these students about solar astronomy. I'm much better with kids than adults, by the way. But I was lecturing these kids, and I said, you know, solar flares are awesome, man, and here's what happens, and it does this and this. But we probably won't see one today. You guys come on over and look through the look through the telescopes. And when I first looked through it, blam! This gigantic flare had already erupted, and it was right in the middle of the sun, and heading right at us. Not like the coronal hole was heading right at us, but in reality, the flare was actually coming towards us. If any of you have seen a flare in a telescope, it's a really bright white balloon of super heated plasma that just erupts out of a small portion of the sun around a sunspot usually. It enlarges, gets brighter than the rest of the sun in the hydrogen alpha image. It's magnificent to watch. It's unbelievable. And then it just goes away in about 7 minutes, 7 to 10 minutes usually. Very unusual to see it. Hardly ever lasts long at all. This flare lasted for 47 minutes at X class, which is the highest rating for a flare. You have C, M, and X. Those are all just, you know, NASA assigned numbers. It means the strength of the flare. X is the strongest flare you can have. This thing went off in the middle of the sun, aimed right at the Earth. It was a big deal. And it was, I almost said a bad word there, sorry. I was so excited. It was a super big deal because I got to share it with 200 ninth grade students out of school who'd never even seen a telescope, much less looked at the sun through it. This is what it looked like on the NASA SDO satellite image. That's what a $840 million image of the sun looks like. Yeah, I know. This is what it looks like on a $5,000 telescope. This is the calcium image here. This little bright area, that's the actual solar flare. This is the sunspot group, or the active region that caused the flare to occur. These are real images, videos taken by little kids at solar telescopes. There's nothing to this hobby. Okay, these are people who have never seen a telescope before taking these images. This was the white light or photospheric view of that same event. You usually cannot see flares when you look at the photosphere because the flare is not bright enough to overpower the other wavelengths. Sometimes you can. This time you couldn't. This is the hydrogen alpha view. It's in monochrome because astronomers use monochrome cameras normally to take images. This is actually fiery red, but it's easier to see in monochrome, so that's why we all use monochrome cameras. Those are Georgia clouds going by. But what I want to get at here is that with just a little investment and a little bit of time, you can watch this happen in your driveway, man. I mean, you can go in your backyard and watch this happen on the sun. It's an incredible thing to witness. Here's some more images. This one is intentionally reddened up a lot. It's hard to see, but that's close to the color you see in the telescope when you have a hydrogen alpha telescope. Okay, am I out of the way enough? Can you guys see over there? This is an image. These are all taken by little kids, by the way. This is an image of the sunspot group that caused the flare, and this is the calcium wavelength image. This is near infrared. This is all visible light, and this is near ultraviolet. So red, everything, purple. Easily done, off-the-shelf equipment. This is a hydrogen alpha image taken at the same time, but just before the flare occurred. Okay, and this is what the sunspot group looked like before that flare, and that's what it looked like about 3 minutes later. I mean, if you're an astronomer and that doesn't excite you, then something's wrong with you. You should check your pulse or have some more wine or something, because that's awesome. And again, anybody in this room in 2 hours, Mark Townley, Gary Palmer, me, Richard Bell, Pedro Ray, could have you taking this image in 1 day, easily, nothing to it. So if you want to get into something and do some imaging of astronomical stuff, this is way easier than sissy nighttime astronomy. Okay, this image from start to finish, 6 minutes max. Okay, image of the Veil Nebula at an acceptable level, 100 hours. Right? Am I right? I'm just teasing. I love all astronomy, but I like to tease the nighttime guys. I want to tell everyone how great I am, what a great solar imager I am, and how accomplished I am at imaging. But I mean, there's nothing to this hobby. It's just point it up there and hit the buttons. Photoshop a couple minutes and you're done. Okay, there's nothing to it. Am I causing a stir in the audience? Sorry. Calcium image at the same time before the flare occurred. Right after the flare occurred. Look at that. Boom. Boom. I mean, it's just amazing what you can do with current available stuff. Here's some close-ups. Now, of course, I got really excited about it, so I pushed all the kids out of the way. So let me take some pictures. And, these are some images I took really quickly between classes of this flare after it started subsiding. It's incredible. I mean, it's real. It's right there. You can do it tomorrow if you want to. There's nothing to it. Man. And I would say, why not share it with a bunch of people? I mean, there's no better way to inspire yourself than to inspire others. So go share it. The impact on Earth, it's debatable, but this is from July 23rd, 2012. This is the big story that's been on the web about this. This CME came off and passed the Earth. That CME came off and luckily did not pass the Earth, or we wouldn't be having this lecture right now. For those that don't know, this diagram shows the sun in its very center. This is the sun's corona, and here's the Earth, Venus, Mars, and these are two satellites that monitor the sun. This is extremely precise data taken after a couple of years of studying that event. This CME would have knocked us into the Stone Age. Okay, this is a Carrington class event. I can't tell you that 100% certain, but I would bet my pension on it. Had we been on the other side of the sun at that time, it would have been a totally different world today. It's a very, very fragile environment we live in, okay? The distance from us to the sun is a cold, long way. Blasts of radiation come off the sun routinely that could vaporize the entire atmosphere of the planet. We've been very fortunate to still be here, and there's a couple of reasons why. But these type of events happen 3 to 5 times a day, CMEs, during solar maps. If I ask 100 people at the Air Traffic Control Center where I used to work, the busiest facility in the world, what's a CME? Not a single person can tell me what it is. Yet it affects their job every day. We had to reroute aircrafts 4 different times during this solar cycle, and no one even knew what they were talking about when they said solar storm. Yeah, whatever. You know, this is important stuff that no one knows. One more time? Okay, here we go. Boom. End of life. This image, maybe not end of life, I may be exaggerating a bit, but that was an extraordinarily strong solar flare. You see it? Please. Thank you for having a pulse. Yes.
Stereo A was right in the middle.
Yes.
What was the effect on stereo A?
It was completely blacked out for about an hour and a half until the chip cooled back or got back reset. You can see the image. It's on the NASA SOHO, stereo, and SDO sites. The images from all of them. Stereo A is a little bit decrepit now. It's not taking as good of images as it used to, so it's not the best image you'll ever see. But it was completely shut down by that. This is Alberta, Canada. Any Canadians in here? Oh, good. I can make fun of Canadians. These are aurora that I shot 4 weeks ago in Alberta. This is an astronomy meeting there. The last time I saw those, I was 17 on the deck of a submarine in the Arctic Circle, and I really didn't take note. I didn't really even know if they were. But this was a fantastic thing to see. I was really hoping you guys were going to get them here last week, and so I think some of you did. They're caused by solar wind. Okay, the Norwegians did all the research on it, but it's something that occurs after a major solar storm. They float and they just waft in the air like a veil on something, you know, like a princess veil or whatever, and they just kind of flutter, and it's very, very, very spooky to watch. Impossible to describe with words. Mark Townley can tell you. It's unbelievable to see. They are beautiful. These green colors and the blue and the purple are all caused by oxygen and nitrogen at different altitudes being energized by the magnetic fields from the CMEs, and they glow, this ghostly glow. That was the first time I've ever been able to take a picture of it. I was so excited to post them. I couldn't wait until Mark Townley saw my aurora photos online. But those are caused by solar storms. Observing the sun quickly. Hydrogen alpha telescope. Calcium telescope. White light telescope. 3-way mount. Cheap celestron mount. A bunch of counterweights. The main ingredient is a big ton of happy kids. Okay, this is how you visually observe the sun. Does anyone here have a calcium scope besides Mark Town? Okay, but a lot of people have white light telescopes or solar filters on their telescopes. They're all breathtaking to look at. They're all fantastic views. In my opinion, I could look at any one of them all day long. I'm about to add sodium to my program once I get back with a top secret project from a top secret vendor. But I'll be shooting in sodium here shortly. A pressure-tuned 100mm sodium scope is on the way. But observing the sun this way is fantastic. Like I said, this is a Lunt 100mm double-stacked Etalon, and it doesn't really matter. All that stuff is just what astronomy club people brag about back and forth. It's really irrelevant. It's a great scope. It's readily available to the consumer. You can get it from a 40mm up to a 230mm if you want to. It doesn't matter what telescope you have, as long as you have a passion when you share it with somebody. You can image through any of them. You can do any of this hobby through any of these telescopes. I'd strongly suggest, if you're interested at all, go get one and start looking, because it's awesome. It doesn't matter if it's solar max or not, because there's always chromospheric activity on the sun. The old adage about, oh, if the sun's in solar minimum, who cares? That's just for white light observing. There's not much activity during the solar minimum. But during solar maximum, or any time, the chromosphere is always busy. So take a look. Imaging. I'm sorry, this is visual observing again from the driveway. When you're imaging the sun, this is my setup at Outreach that I use. Each wavelength visually for the students. Then we walk over here to these 3 iMacs. I use some software called Astro IIDC, which probably no one's ever heard of. It's the greatest imaging software ever written, but it was on the Mac, so it never sold. The guy went out of business. These are the same 3 wavelengths and smaller apertures that I run to these 3 iMac computers. Students come right up. I started this whole thing for handicapped students, because in the United States, I don't know about here, but every young person is publicly educated. We don't exclude anything for physical handicaps or whatever. I know some countries do. But we educate everyone. So I had a lot of handicapped students, or perhaps mentally, different students, and I would run them all through here because they wouldn't hurt themselves climbing up here. But then it got so popular that all the students wanted to go over here instead of here. So now I'm running through both. I force them to go here. But they take their own images through here. And some of you saw the Astronomy Photographer of the Year awards on Wednesday night, where Alexandra Hart waxed the floor with my image. She beat me like a bad habit. But that image was taken through this telescope on this computer by a 12-year-old girl. I was sitting there with her, and I said, "Hey, look at this, check this out. Press this button, do this." And there's nothing to it. Here I am accepting an award at the Royal Observatory in Greenwich for something that took 90 seconds maximum, with me and some kid having a good time. There's nothing to the hobby. That's what it looks like from the driveway of the Ramsden Solar Observatory. I have buildings 70 degrees up all around me, so I get about 1 hour to look at the sun. And I live in the middle of downtown Atlanta, so it's always horrible. This is a video camera from PGR. And the way we image the sun is the way we image anything planetary or anything else. You take about 1,000 images, and you stack them together, and you mess with it in Photoshop for a while, and then you put it on the internet and brag about it. These video cameras are monochrome. Some of us brag more than others. It's very simple to do. This is a DSLR camera. You can take images of the sun with that if you want to as well. You can stick this in the end of this. It doesn't matter how you do it. It's still fun. Monochrome web cameras are usually the best way to get results. But if you got a camera, if you got an iPhone, stick it on the eyepiece, and next thing you know, you've got a solar astronomy group on Facebook, and you're touring the world. There's nothing to it. In fact, here's some images taken the day before I left, just to show you how easy it is. This is all. None of these images were more than 3 minutes total from capture to done. That's the sun in calcium. There's the sun in hydrogen alpha. And this is a little bit of photoshopping and a lot of data. A little prominent shooting off the top there. I promise anybody in this room can do this by the end of tomorrow if you wanted to. Sunspots, white light. It just kind of looks like this was not taken the day before I left. Looks kind of like a Big Dipper, I thought. This little white area in here, if you were to see a solar flare in white light, it looks similar to that. Okay. Another hydrogen alpha image. This is pretty close to what it looks like in the telescope. for those of you that don't have an H-alpha scope. I mean, it's fantastic. It's a beautiful thing to study. Again, on the internet, you can get several different wavelengths of light to look at the sun 24 hours a day. From here down, these are all what they call extreme ultraviolet images, except for that one. And you can't see these wavelengths from inside the Earth's atmosphere. So SDO images in wavelengths that are not possible to see from down here. So you can get a pretty good idea of what's going on in the sun before you go out if you want to. These are all taken at the same time, showing the same area in different wavelengths. That's free of charge on the internet whenever you want to use it. This is a movie compiled by my friend Steele Hill, who works for NASA. Anyone know how many days it takes the sun to rotate at the equator? Yes? Go ahead. You know?
39.
About 27, 28, 24, something. 24 at the poles and 27 at the equator is generally the accepted number, but it can vary because the sun's not solid. When it rotates, this is what it looks like in extreme ultraviolet. All these bright areas are flaring regions or active regions. All these darker areas are cooler gas. And this is real. This is not some television show or some internet sci-fi stuff. This is reality. Easy to see. You can image it. You can take a movie very similar to this if you want to. It's great to show students because it gets them inspired in science. This is 3 years worth of revolutions of the sun. When you put them all together, it looks like that. Some valuable data. There was a 10-year-old kid at the Royal Observatory yesterday, and I said, can anybody tell me why, what the distribution, 20 to 60 is generally where degrees south and north is generally where active regions occur. And I said, is there any reason anyone can tell me why that might be important to us, to our existence? And this little boy raised his hand and said, because we orbit the equator. I said, yeah, that's exactly right. The reason we're still here as a planet is because most of them go this way and this way. They don't come out directly. We orbit this line over here. And that little coincidence of physics is called gravity, has allowed us to exist long enough to evolve into a species that's contemplating the fact that this is why we exist, which is also pretty incredible to me. That's the sun. What is the Charlie Bates Solar Astronomy Project? Nonprofit 501c3. Do they have nonprofits in the UK? Okay, you get a tax break for putting your money into a charity or whatever. I started the nonprofit because I never had any intention of doing this or traveling around the world. My love is going to schools and teaching kids. People keep asking me to come speak to them, so I did. But the formation of the nonprofit was so that the $250,000 or so that my wife and I decided to put into the program, we could take a tax deduction for it. So that's why I started the nonprofit. Then I had a lot of people that wanted to participate, and I got so much positive feedback from it that I started giving away telescopes to other people. I had plenty of telescopes. I wasn't using all of them. I went through a bunch of stupid decisions until I got the telescopes I had. I know none of you did that. But instead of selling them, off and trying to penny pinch everybody to death, I just took the scope and gave it to somebody else and said, hey, go do some outreach. Here you go. The glasses that I bought, I had tens of thousands of pairs of glasses. I'll just give them to you. Why don't you go do some outreach and see what I'm seeing? The outreach has almost become the subject of the outreach because now I'm outreaching outreach, which is strange for me. But if you've got all this extra equipment sitting around and you're not using it, why are you holding on to it? I mean, why is it sitting in your garage in a box? I don't understand that either. I can see if you got a $40,000 AP refractor or something, but if you got a bunch of $1,500 scopes that are sitting in a box gathering dust, take them out of the box and give them to someone and let them use them. I mean, why? So I just started giving everything away, much to my wife's chagrin, by the way, because that was her European vacation. Every time I gave something away, she's like, yeah, I could have went to Morocco for that. But she finally got the idea. So we started giving stuff away, and other people started joining in and using my name, which I was shocked by. Mark was one of the first ones. Hey, can we do some outreach? Can we, you want to do some outreach for Charlie Bates? Yeah. Well, now it's in 17 countries. Last year we saw over 300,000 students. And when I say saw 300,000 students, I don't mean like the Royal Observatory sees them or like NASA sees them, where they give them a pamphlet and push them out the door. I mean, we sat with students at the telescope and explained what they're looking at and gave them a lecture about science. Okay, personal involvement, hands-on personal involvement. We did that over 300,000 times last year. I did it 80,000 plus times myself. There's nothing to it. It's easy and it's fun. Okay. The philosophy we adopted when I started the program, no politics or religion. I don't care about. Was that a Roman soldier? Is that a
Just a cat.
I don't care about anyone's politics or religion. It doesn't matter to me what those are. I don't participate in that stuff. But I'll ask the same question I asked last night. Has anyone in this room ever had a political debate with someone, an argument, where the other person changed their mind and said, you know, you're right, I am a dumbass. I mean, you're right. I don't know what I'm talking about. Anybody? Me neither. Well, here's the simple question. Why bother? Who cares? I mean, it doesn't matter. It's a way to argue. Some people like to argue. I just stay away from that. It's irrelevant. I don't care. I don't allow it. I mean, I do have strong views politically and maybe even religiously, but it's pointless for me to try to convince you of my views, and it's just a waste of time. Whenever you bring it into a group, it always fractures people. It always pisses people off. Forget it. Egos, number 2. Ego, from the Freudian text, I believe, id and ego. There may be, but I doubt there's anybody in this room that can outshow me with equipment, okay, or whatever. Who cares? I don't care what equipment you have. It doesn't matter to me. And I'm glad you have fancy equipment. It's great, but it's irrelevant, man. It doesn't matter what you have. I mean, that's great. But if you set up your scope outside at the World Observatory, I'm just using that as a hypothetical example, and you talk to each other about how great your scopes are, while herds of kids walk by unattended to, you're not really getting the whole point of it, you know. Egos in the United States have basically destroyed the astronomy hobby, just about. They have completely excluded anyone who's not already an astronomer, are basically excluded from the hobby because they don't want to get involved in all that political bickering and infighting and all that stuff. Take it easy, man. I mean, put the fun back in astronomy. You know, that's what this group does, and that's why I'm standing here talking to you, because I really respect that. Egos are not allowed in anything I do. I don't care. No pay. Again, these are just my philosophies. I'm not preaching to anyone here. I'm just telling you this is how my program has become so successful. We don't pay anybody. There's no salaries. There's no charge for anything. When it comes to a point where I have to make money doing it, then that's when I'm going to stop doing it. It's science. It's the natural world. It belongs to everybody. You sharing it with someone else betters you. You get more back than they do. It's called improving your community through sharing science. I don't allow anyone to charge for anything. Copywriting images and all that stuff, you know, I understand some people got to do that and they sell their images. That's fine. I don't allow any of that stuff in my program. If you share the image, whoever wants to use it can go use it. Nobody is going to steal your image off Facebook and sell it, okay? I got news for you. There's a million imagers out there, and none of them are as good as Damien Peach, who I did an interview with. Nobody has come close to Damien Peach. Until you surpass Damien, no one's going to steal your image and sell it, okay? No one. It's cool to, you know, put a little copyright on an image, I guess, if you want to, but slathering a 40-point font across the front so no one will steal your image is ridiculous, man. You are ruining the whole effect of your image. Just give it away. I mean, what? Okay. Finances and taxes. Being a nonprofit, it is required by law in my country to have your financial data posted on your website if you're a nonprofit and you maintain a website for the nonprofit. So that's what I do. If you are participating in a nonprofit or you donate to one or whatever, and they don't have this information, transparency, you should probably take a really close look at it. Okay. There are several astronomy nonprofits that are not really nonprofits legally, and we'll just end it with that. I'm not saying give away your entire catalog of stuff, but if you're putting a 5-inch Beta film filter from 10 years ago on Astromart and asking for $4 for it, you've got a screw loose, man. Just give it away to somebody. Let somebody use it. Let them have it. If you're a store vendor and you're doing that, just give it away. That person then becomes interested in astronomy and then comes back to you to buy something better. What are you holding on to it for? What's the deal? The bottom one. Look, it's all about fun. It's about sharing science with the community, and that's what's important. If you're in an argument and you're an astronomy club manager or something, or you're in another club and you guys are arguing about something, 99.999% of the time it is complete BS, and you should just stop talking. There's nothing worth arguing about in these clubs. The purpose of the club is to get more people involved in astronomy. When you're arguing with each other, taking credit, it's my idea, it's your idea, I did it, it's mine, you're driving everyone away. No one wants to be around that. Blunt Solar Systems sponsored this trip, and I appreciate it. There's 2 companies in the U.S. that have actually sponsored my program in the last 6 years ever, and Lunt was the main one, and Astrophysics is the other. The majority of vendors are not interested in this for some reason. You know, they're interested in what's next quarter's profit, but they're not interested in 10 years from now how many people are going to want telescopes. The hobby is dying, if you've noticed. It's not really dying fast, but there's not a whole lot of new people coming into the hobby, nearly as much as there should be. The way you get more people into the hobby is you become very friendly and outgoing and invite them to your meetings. You don't have silly fights. This brochure is on our website. If anybody wants to do any outreach, you're welcome to come join me. And we hand out these brochures to people. Mainly, if somebody gave you these glasses and charged you, my email address is on there. Get in touch with me, because I'll have my lawyers hunt you down till the end of the world. I've had a lot of people do that, and I don't know why. Why would you ask me for 1,000 pairs of glasses, have me ship them to you at my cost to pay for them, and then you sell them for $5 a piece at a show? Can't tell you how many times that's happened in the UK. So if you see anybody doing that, I'd appreciate you letting me know. It's all about giving it away. And even if you're selling stuff, even if you are a vendor, or you do have a profit motive, or you do want to sell images, the best way to get someone interested is to be friendly and get them started. You know? Our outreach events, this is near the end of the lecture, don't worry. Our outreach events typically visual and imaging setups. Here's a bunch of happy kids in Georgia. Here's me at NEAF. This is the new LS50 scope from lunch at the Northeast Astronomy Forum. We go out and we share the science, and we try to get people interested in science by being welcoming and friendly to them. That's basically what we do. Here's some students imaging at the IMAX. We do have a spectroscopy set up. That's really my favorite part of astronomy, is spectroscopy. My other lecture is much more punishing because it goes into detail about spectroscopy. Anyway, we do a lot of spectroscopy at outreach events. Does anyone have a Shellyak spectrograph in here? Shellyak product? Okay, we'll just visual observing multi-wavelengths. Notice more happy kids looking at telescopes, having fun. I go to the big shows a lot with the chick magnet. I didn't ship it to London, but it's a joke. We try to give out handouts to everybody, and NASA supplies these handouts, or else I just go buy them. And we give away these things to people to get them interested in science. I'm in 17 countries now, hoping to be in about 159 countries before I die. Probably unlikely, but when you've got people in Malaysia using your telescopes and wearing your solar glasses, and they put a poster on your Facebook page or whatever, send you an email, that's a fantastic feeling. Anybody in here could be up here giving this lecture to everybody. There's nothing stopping anybody in here from doing the same thing. It's no big deal. People always say, well, you're doing such a great thing, you're such a great person. I'm only doing what everyone should do anyway. I mean, when I grew up, everybody shared what they had. Everybody shared their passions with each other, and we had a good community. There's nothing special about this program. Let's see. There's Pedro Ray right there in Tunisia, and that's me in the back. Every day in Tunisia, every member of that outreach club showed up every day and did an outreach event all day long, and we had thousands of kids come through at this one event at the Science Center. It was a fantastic thing. There's Australia with me, India. I had to kind of cut off India for a while because everything I shipped there got stolen. You know, that kind of sucked. But we do have a lot of stuff in India. There's the chick magnet one more time. Notice the rims. Yeah, tell you a funny story about that. In Atlanta, Atlanta's that's the most per capita of gay men in America, which is, who cares? But this is also the gay pride symbol in America. And I live in a neighborhood in Midtown Atlanta, and it's all good. I went to school, everybody's gay. But this van gets so much more attention than it was really intended to get. And that also tells you how little people know about the sun. This is the sun spectrum, man. I mean, it's not modeled after, it's not modeled after the gay pride logo. The gay pride logo is modeled after it. But people don't even understand that that's what it is, because no one knows anything about science anymore. International Sunday, you guys did a fantastic job on that. This year or next year, we're going to have it June 21st, and I'm going to launch that from Germany. That's the plans right now. Bresser Europe is going to sponsor all that. So I'm really looking forward to that. I hope you can participate again, because these images here were really cool. The whole Lunt Fort thing goes over well in America. So I hope that you get to do the same thing. I appreciate you coming and listening to my lecture. You can read all that if you want to, but I do want to say one more thing. Everywhere I go, I don't spend any money on travel, any nonprofit funds. If someone donates $100 to my charity, I feel it to be my duty not to spend it on BS for myself. I spend it on glasses and telescopes to go to kids. It all goes to students. So when I get invited to go somewhere like this, the other side has to pay for expenses. I don't charge any fees. They just have to get me there and do a hotel. Lunt Solar System sponsored this particular trip for you guys. There's no fees involved. It's just expenses. I can't, with good conscience, donate your $50 donation to my hotel bill for me having, breakfast. It's just crazy. So I take with me something of equal or greater value, equipment-wise, and give away to everyone. That's what I've done. That's my hallmark. We gave $40,000 or so worth of telescopes to the Australians. They did raise a lot of money to get that. But, Tunisia, we gave them a nice Coronado solar telescope. I'm giving away all my Coronados now because I just use months on them. And I tried to give the Astronomy for Fun group, you guys, a $14,000 Coronado double-stack 92 solar telescope. That's what I had. Okay, I was really, really excited about giving it to them, and then nobody wanted it. I couldn't. I've never had so much trouble giving something away that they said we won't put that to the use it needs to be used. Give it to someone else. I was perplexed a bit, and then I was just very touched by that, because had that been some other people in this hobby, they would have said, "Sure, I'd love to have it," and then sold it for whatever they get out of it. This group said, "No, let's put it where it's going to be used." Mark and Gary worked that out, and it's now at the Herschel Show Observatory in Greenwich. And within 10 minutes of getting there, we had 50 kids looking through it. Right, Gary? We set it up there. The people in that science center are fantastic, man. I mean, it was a breath of fresh air after spending 4 days on Baker Street, let me tell you. Put it to use, and the kids were looking through it. It just warmed my heart, and I've never had anyone turn down a scope donation, and I'm just, I'm touched by that. I don't know what to say to that, except your generosity is definitely benefiting a lot of students, and will benefit a lot of students in that observatory site. So I'm very grateful. Does anyone, this is not the point where I pass the tin around, by the way. Does anyone have any questions or comments? Or I do want to say thanks for having me here. It's the last 6 months have been pretty extended. Yes, sir. Thank you for the applause. Nobody's as surprised as me to hear.
The massive flare that 2012, how often has something like that been monitored?
Monitored 24 hours a day.
Yeah.
There's several
How many
monitoring systems.
systems of that ferocity?
The numbers say once per solar cycle, there's a high chance of having a flare of X14 or greater. There's no predictable, reliable way to forecast solar flares. Anyone who tells you there is, they're nuts. There's no reliable data to give you any accurate forecast on solar. They have statistics and percentages on how likely it is. Once per solar cycle, X14 is right. That's the answer to that question. Okay. Good question. Thank you, young man. Anybody else? Okay. That's what I always say to students. I'll be mingling around then, and I have glasses and spectrographs. I'd love for all of you to have one at least. I'd love to put slides on. Definitely. They're very cool. And thanks again for your time.
Okay, don't go anywhere. You're not allowed to go anywhere just yet.
My plane leaves in 10 minutes.
You don't escape. You've obviously given a lot to solar astronomy, solar outreach in the UK. Okay, and everybody's incredibly grateful for that. Okay, and I know Richard for weeks now. Okay, has been. Well, you didn't mention it. I know for weeks Richard has been plotting and planning, and well, I'm going to hand over to Richard. He's got a whole load of goodies.
Is Rob still online? It was Rob's idea.
He was Rob's idea.
Rob's idea, and I know it's bad. Okay.
It's still there.
As you're the sole king, leave me alone. Solar crowds.
They're making big job, Rob.
Well, now it's good.
Real.
Suits you, Steve.
Yes, go on.
A personal thank you. We know you're such a big Star Trek fan.
Oh my God. Fantastic. My own track orders. Now the Federation of Planets. 3D printed. I will cherish this forever. Thank you. I am a huge Star Trek fan.
Because we're all up to its hint in the UK. There's a couple of months
Yeah. Thank you so much. You're very kind. I appreciate it. Oh, hold that. All right. All right. It's good to be king.
We even had you a throne.
Well, you know I can't miss the opportunity for a selfie with this. But one more. Everybody stand up and take a selfie. Rob Black, I owe you.
It suits you, Steve.
Thanks, everybody. That's it?
with my friend here,
Oh, there's more.
that I owe money to.
Oh.
We've got a bag of spot.
Oh,
that's
over.
Ah,
Perfect.
when you get below 100. Thank you very much. So we have a quick break, tea, coffee, and then we'll come back for questions.
Thank you very much, everyone. Thank you.
Thank you for being with us, Rob.
Yeah, cheers, mate. I'm glad you liked the stuff, mate.
Oh, he's reveling in it. Right, we'll stop the broadcast now, Rob. There we go.
Okay. Have a good one, guys.
Thank you, Rob.
See yous.
Bye-bye. Good day.